For the lazy people out there, including me, let's do a quick Google search of how the Google engine actually works. And here it says Google looks through hundreds of billions of web pages and other content stored in our search index to find helpful information. All of this sounds cool, but what about the actual code of how all of that works and a bit more information? Well, don't you worry, in this video I'm going to go over all of that. But before we get into the juicy part, we got to start from the very beginning. In the early 1990s, when the internet was rapidly expanding, search engines like AltaVista and Yahoo had low-quality page ranking results since they relied on basic keyword matching to rank the pages. The lack of context and phrase variations were the main issues since keyword matching doesn't account for the context in which a word is used for. For example, the word Java could refer to the programming language, an island in Indonesia, or a type of coffee. It also fails to consider synonyms or different phrase structures. For example, buy shoes online and online shoe store might be treated as completely different queries even though they represent the exact same thing. So if you searched how to fix a slow computer, the top 3 results would look something like this, with the first page being exactly what we want. The second one looks pretty good too, but the third one is something completely different, which wouldn't even make sense being there. And of course, this is all made up just for the purpose of this video. Let's take a look at this in more details. The first page is matching all of the keywords with the query, which is why it's ranked the top page, with a few keywords in the description. The second page only has slow computer in the title since they have to be exactly equal to your query. And in the description, you also have fix a slow computer, which is also why it ranked higher than the one under. So the title also has slow computer, but in the description, you would have slow computer and computers. And so all this was fixed with the Google engine, but before we get into that, let's start from the beginning. 2 students at Stanford University, both with PhDs, recognized those limitations of the early search engines. They wanted to create a more efficient way to rank the pages, one that could better reflect the structure of the web. And their names are Larry Page and Sergey Brin. They came up with an idea called backlinks, which are presented in other websites' traffic coming onto your own site, and their inspiration came from how academic papers are cited, or citations, where the importance of a paper is how many other papers cite it. The concept behind backlinks was when a web page would be linked by many other pages, it would be labeled as a valuable resource, and so that was the foundation of their ranking algorithm, which they called PageRank, and it depended on the backlinks. After inventing this concept, Page and Brin began developing a search engine that would use PageRank to analyze the web's link structure. Their initial step was to build a web crawler, which was named Backrub, named for its analysis of the web's backlinks, which is also known as Google Now. And so this crawler would visit the pages, follow the links on those pages, and store information about each of those pages' backlinks. The crawler not only collected data on which pages linked to which, but also evaluated the quality of those links. For example, a link from a highly reputable site, like a university, would be weighted more heavily than a link from a less reputable site. They then developed an algorithm to calculate the page rank of each page based on the quantity and quality of the backlinks. The PageRank score essentially represents a page's authority or importance. The PageRank algorithm was based on the concept of the random surfer model, where a web user randomly clicks on a link. The likelihood of landing on a particular page determined its PageRank score. And with that in place, they needed to build an index that could store and organize all the web pages their crawler found. This index would allow them to quickly retrieve pages relevant to a user's query. They developed a simple search interface where users could enter queries. The search engine would then return results ranked according to PageRank scores, producing more relevant and reliable results than existing search engines. And now let's talk about the web crawler code, but of course, we have a problem. The full source code has never been released, but modern open source web crawlers still exist like Heritrix or Apache Nutch, which are both written in Java. I found a basic example of what a crawler would look like, which does not replicate the exact functionality of the original Backrub crawler, but will still give you a sense of how it works. And this is going to be the full source code. And for those of you that don't understand Java, I'm going to go over this in detail so that anyone can understand this. But we're going to start at the very top with the imports. I'm going to go over only a few of them to not waste any time, but the first one is going to be java.util.hashset, which in this code is going to be used to store URLs that have already been visited to avoid revisiting them. The second one is going to be java.util.linkedList, which implements a queue to manage URLs that need to be visited. And the last one is going to be JSoup, which is a library that provides methods for connecting to web pages and parsing their HTML content. Moving on to class definition and variables, with the first line defining a public class named Simple Web Crawler, and a class in Java is a blueprint for creating objects or instances. So think of this as an object where we're defining variables. And the next two lines are private fields where HashSetString defines links. So all of that is a data structure in Java that implements a set or a collection that does not allow duplicate elements, specifically for a string value. Under that, we have our queue, which is a collection that follows the first in first out principle, where elements are processed in the order they are added. So think of this as a line of people where the first person to get in is also going to be the first person to get out. But in this case, it's a line of strings or URLs. Under all of this, we have the actual crawl method, where the queue.addURL adds the initial URL to the queue with the website URLs for the crawler. Under that, we're going to have a while loop, which continues as long as there are URLs in the queue to visit. Then we're setting the current URL to be queue.poll, which retrieves and removes the next URL from the queue. And under that, we have our if statement, which checks if the URL has already been visited, and if not, it proceeds to fetch and parse it. Now we're going to take a look inside of the try and catch method. So here we're going to be fetching and parsing the page, where the first line, we're setting the document variable to be jsoup.connect, which connects to the URL and retrieves the HTML content of the page. So the document is going to be the page. Then the next line, we should already have an idea of what it does as web developers. It pretty much just looks for all of the anchors, so all of the links, with an href attribute, which is going to represent links on the page for other pages. And then the third line adds the current URL to set of visited links. Under all of this, we're going to have a for loop for processing links on the page, where the first line iterates over all the links found on the page. Then the second line extracts the absolute URL from the href attribute of each link. And then this if statement checks if the new URL has already been visited. If not, it gets added to the queue for the crawler to visit later. And now moving on to the exception handling, where here it's going to handle any exceptions that occur when trying to connect to or fetch the web page. So if we get any errors, then we're going to go right in here and we're going to get a console log that's going to say for the URL that you're on, and then it's going to give you the actual error message. And so after the exception handling, we have the actual main method, which runs whenever the program starts, where the simple web crawler, we're creating an instance of the simple web crawler class. So think of this as creating a new object. And then under that, where it says crawler.crawl, and here it starts the crawling process with the specific URL. And as a quick summary, the links variable stores URLs that the crawler has already visited using a hash set or fast lookups and to avoid duplicates. Then the queue variable manages the order of URLs to be visited using a queue implemented by linked list. And lastly, the constructor initializes these fields so that when you create an instance of simple web crawler, it starts with an empty set of visited links and an empty queue of URLs to visit. And again, this is just an example of how a crawler works. But as we all know, we run into issues throughout our projects as programmers, and developing Backrub and PageRank was computationally intense. They had to deal with massive amounts of data and required significant computing power, which was scarce at the time. They used Stanford servers to process and store this data, and early tests of Backrub produced impressive results, leading them to believe they were onto something revolutionary. They began sharing the search engine with fellow students and faculty at Stanford, who quickly saw its potential. And after all of this, here's the actual transition to Google. As this project grew, they decided to rename it from Backrub to Google, a play on the mathematical term Google, which represents 1 followed by 100 zeros. The name reflected their mission to organize the vast amount of information on the web, and in 1999, they secured the first funding from Sun Microsystems co-founder Andy Bechtolsheim, who famously wrote them a check for $100,000 before Google was even officially incorporated. This funding allowed them to move out of their dorms into a garage in Menlo Park, where they officially launched Google. And as always, if you enjoyed this video, make sure to leave a like and subscribe to this channel. This video did take me a long time, so I really do appreciate everything that you guys do, and hopefully see you